everybody, this is Bodechon here. So we're going to look at 2C today. It says, I can use the International Union of Pure and Applied Chemistry nomenclature for translating between binary ionic and binary covalent chemical names and chemical formulas. So on your portfolio, it's asking you first to write the chemical formulas. The first question talking about swap and drop. So you have to know what swap and drop is first. So let's check it out. Here's a really good example of swap and drop. So it says swap and drop method, the oxidation number only of each atom is swapped and then written as a subscript instead of a superscript. Might sound a little confusing, so let's do an example together. So we're going to write the chemical formula for lithium oxide, okay? So the very first thing you need to do is write down what elements you're using. Lithium is Li, and oxide is really oxygen, right? So O. If you go on your periodic table and you look at the oxidation numbers, you need to write that with it because we're writing ion notation here, okay? So the ion notation for lithium is Li plus. Remember, there's an understood 1 there, and then oxygen is a 2 negative. So we're going to go ahead and write that there. Now, in order to make this a formula, we have to see how many of each element needs to be there in order for them to bond, okay? Remember, they're going to bond when both atoms end up with a full octet. So we have to have a total charge being neutral or 0 in order to do that. So the easiest way to do this is with the swap and drop. What you're going to do is you're going to ignore the plus and minuses. Just forget that they're there. You're just looking at the numbers, okay? You're going to take the 2 for the oxygen and you're going to swap it and put it on the bottom, on the subscript for lithium. So it wasn't a superscript for oxygen. You're going to swap it to that lithium and you're going to put it down as a subscript. You're going to do the same thing for the lithium. The plus is really 1, right? So you're going to take that 1 and you're going to swap it to oxygen and you're going to drop it down from superscript to subscript. That's why we call it a swap and drop. So you swap the oxidation numbers with the other element and then you drop them from a superscript to a subscript. And then that's your answer. So then you write it Li2O. The 1 is understood, right? I don't really have to write 1. We just know that there's a 1 there, just like in math class. And here's how we can calculate if it's neutral or not. In a different way, your charges just have to equal 0. So if I have my lithiums being positive 1, I need 2 lithiums being positive 1 and positive 1 equal positive 2, right? For every 1 oxygen I have, that's negative 2. So if I do positive 2 and a negative 2 together, combining them, their total is going to be a 0 charge. So I know this is correct. These actually would bond. They would form full octets, okay? So let's try the examples on your paper. The first one is lead and oxygen. So go ahead and write lead, which is Pb, and Pb is right here. You can see it's in group 14. So go ahead and write the oxidation number 4 plus, and then the same thing with oxygen. The oxidation number is 2 negative. Swap it and drop it. So that 4 comes down to oxygen and it goes down to the subscript level. The 2 from oxygen swaps to lead and goes down to the subscript level. Now, this is the answer that you get with swap and drop. However, there's a lowest common denominator here, right? 2 and 4. So we need to go ahead and take it to the most simplest form because this is how we're going to form bonds, okay? So this is not how we form multiple bonds. This is just how we form a bond with lead and oxygen. So it needs to be in its very simplest form of how many we need minimum in order to form a bond. So the lowest common denominator here is 2. So go ahead and just divide that by 2 so you get 1. It's understood. I don't need to write it. And then 2 into 4 is 2. So this is the very basic formula of how we would bond lead with oxygen. For every 1 lead, we would need 2 oxygen in order for them to form a bond to have a full octet and be stable, okay? Let's try another one. This one, we are using lithium and oxygen. So go ahead and write lithium, and the oxidation number is plus, which is really just plus 1, right? And then oxygen is 2 negative, swap and drop. So you end up with Li2, because the 2 swapped and dropped down, and then O, 1. So that plus is really 1, and we swap it and we drop it, and it's just going to be a 1. We do not have to write, it's just understood. Okay, same thing right here. We're doing calcium and fluorine. So if you go ahead and you write calcium Ca, get the oxidation number, it's going to be positive 2 plus, and then you're going to write fluorine, which is just F, and the oxidation number is really -1, so all we have to write is negative, right? Because the 1 is understood. Swap and drop that down. So that 1 comes over to our calcium. It's understood we don't have to write it. And the 2 goes down to fluorine. So for every 1 calcium, we need 2 fluorine in order to form a bond together and to have a neutral atom. And doesn't that make sense? If I have positive 2 over here, I would need -2 to balance it out. So I would need 2 of these in order to equal 0, right? Okay. Notice we're not writing our negatives and our positives in our formula at all. Okay, those disappear. We don't, it's just not necessary. Okay, so let's go ahead and learn how to write these. So now we're doing nomenclature, which is how to name compounds, and we're going to start with ionic compounds, okay? First thing you do, write the name of the element. The metal always goes first, and then the non-metal. Then you're going to change the ending of the non-metal just to IDE, just the very end of the word. So let's try a couple out. Super simple, you guys. NaCl. Na is sodium, so I write sodium. Chlorine is Cl, so chlorine. Now, second step, change the ending of chlorine to an IDE. So it's going to be sodium chloride. And that just is representing that, hey, it's formed a bond. Now it's a compound, okay? Try another one. Ca is calcium. Ca is chlorine. So it's going to be calcium chloride. So I change that ene, the I-N-E, to I-D-E. All right. Next one, Mg is magnesium, N is nitrogen. Now I need to change the ending of my nitrogen to an IDE. So magnesium nitride. Okay. And that's how you name a compound for ionic bonds. It really is that simple. Covalent bonds are slightly different. We're just going to add another step. Okay. So we're going to do the same thing we did for ionic. We're going to write the name of the elements. We're going to change that ending to IDE, but then we're going to go back and we're going to add prefixes. And these are Greek prefixes, and we're going to add them in front of our words. Okay, so it says add the prefix to the atom element, except if there is only one atom in the first element. So we're going to go through and I'm going to explain that, okay? So here are your examples. S2F4. So the very first thing you do is you could just write sodium and you could write fluorine, right? Just straight from the periodic table, just like we did our ionics. But now we have to add the IED at the end, so we change the fluoride. So we change that, right? The very next step, which is the last step we have to do, is do the prefixes. So notice I have a 2 for my sulfur. So I have to go and I have to look. Okay, di is for 2. So because I have 2, I have to write di in front. So now it's disulfur, okay? I have a 4 for my fluorine, so I need to look at 4. 4 is tetra. So now I need to write tetrafluoride. So it's not fluorine because I've already changed the ide, right? So it's disulfur tetrafluoride. These are a little bit tricky to understand, like when you cut off the word, the spelling, things like that. As long as you're doing this, even if your spelling is a little bit off, if I can understand it, you guys, it's okay. And you can always look up the spelling if you really need to. Okay, so the next one, H2O. This should look familiar. It's water, right? Okay, so I could just write the basics. Hydrogen and then oxygen. Now we can change the IDE. Hydrogen doesn't change, but oxygen does. It becomes oxide. So it's not oxygenide. That just sounds funny, right? So we just say oxide. But now we have to go back and change our prefixes. So I have 2 hydrogen. So 2 is di. So I need to write dihydrogen. And then I only have 1 oxygen. So I need to go ahead and write mono for one, mono. So we say it, dihydrogen monoxide, okay? The next one, CO2. C is carbon. Oxygen, again, you can change that ending for oxygen to "ide," so it'd be oxide, okay? Not oxygenide, just oxide. And then we're going to go ahead and do our prefixes. There's one carbon. Because there's only one in the first element, we do not write mono. I know one is supposed to be mono, but that is the exception to the rule. You do not write mono on the first element, okay? The second element, yes, you do, just like this one, right? Just like monoxide, you definitely want to write it for the second one. But if it's for the first element, you do not write it. You just write the name itself. So just carbon. That's it. Now there's a 2 for the oxygen. So we do want to go ahead and represent that 2 with a di. So dioxide. One last one here to try. P is phosphorus. Cl is chlorine. I would change that chlorine to chloride by adding the IED at the end. Then go back and change your prefixes. There's only one phosphorus. So again, because there's one, I do not write the prefix. If it's any other number besides 1, I'm writing it down. But 1 is the only exception that we do not write for the first word only, okay? Then I have 3-chlorine. 3-chlorine is tri. So I'm going to write trichloride, all right? And this is just something that you're going to have to memorize. So go ahead and start practicing these Greek prefixes. You're going to have them memorized. Make sure they're in your notes for the test as well. And let's go ahead and look at this one. So it says, we're writing it now for covalent bonds, okay? So write a chemical symbol in order, then add the subscripts based on the prefixes. We're now writing a chemical formula when we're given the name, the nomenclature, all right? So the first example is disulfur tetrafluoride. Well, these sound like crazy words. So we need to start dissecting the words to see what element it is. We can see that di is a prefix, and we can see that tetra is a prefix. So kind of ignore those when you're looking at the element, and you can see that sulfur is the element, so S. Well, how many S is there? There's di, and di is 2. So I can go ahead and write S2. And then if I'm looking at this word, fluoride, well, the ending has changed, right? It's really fluorine, so it's F for fluorine. And then my prefix is tetra, and tetra is 4. So I'm going to go ahead and write that 4 on the end. That is your chemical formula, disulfur tetrafluoride. And that is how you write it. You should be able to do this in both ways. Make the chemical formula or make the name. Doesn't matter which one, but you have to be able to do it both ways. All right, nitrogen monoxide. Nitrogen is in, and it doesn't have a prefix, which means it's 1, right? And then monoxide, so oxygen, oxide is oxygen, and mono meaning 1. So I don't have to write any numbers because 1s are understood. Sulfur hexafluoride. Sulfur is S. Because there's no prefix, I know it has 1, so I don't have to write it. And fluorine is fluoride once we changed it, right? So F for fluorine. And then hexa is 6. So I can write a little 6, and there we go for that one. Number 4, dichlorine heptaoxide. So what we're going to do there is find our chlorine. So Cl, it's di, which means there's 2, di for 2. And then oxide is oxygen. So O for oxygen, and hepto, or hepta, is going to be 7, okay? So we're going to go ahead and write that 7. And that's all there is to it, guys. Let me know if you have any questions.